In this section, we're going to talk about partial fractions. So here's the idea. In the past, we worked with rational expressions and adding and subtracting them. So here's an example of that. You have 2 over x minus 3 plus negative 1 over x plus 2. So the idea is get a common denominator. You're going to multiply by x plus 2 here. And you're going to multiply by x minus 3 here, and then that's going to give you the common denominator, x minus 3 times x plus 2. And this is how we add rational expressions. So in the numerator, we distribute. You get 2x plus 4, and then negative x plus 3. So when we simplify the numerator, we get a new rational expression that looks like one rational expression, x plus 7 over x minus 3 times x plus 2. And you can see the numerator and the denominator there. And that's how we would combine those two expressions to be one rational expression. The idea behind partial fractions, or sometimes I'll refer to it as partial fraction decomposition, is to take a product like we have here that I have a box around and break it down into two separate expressions where the denominators are only one factor. So that's probably a little misleading the way I said that, but the factors are specific, they're broken up. Okay, so that's the idea behind partial fractions. So let's see. Here are the steps, and it's different on your paper. I tried to write it a little more condensed here, but basically you have to know how to set up the decompositions. That's the big part. I'm going to type up a special page that will have the different setups so you can see them, and we'll go through several examples so that you can see them. I plan on doing videos for all of the worksheet problems so that you can see those as well. All right, once you get it set up, then it's a matter of getting common denominators, matching the coefficients, solving, and then finally you have to write the decomposition. So those are the steps. All right, so here's our first example. Similar to the problem that we just did, where we have two factors in the denominator. Those are both linear factors, meaning that's x plus 2, meaning x plus 2 is a degree of 1. So that's great. So what we're going to do then is we're going to say this, I don't want to write it that way, sorry. We're going to say that this equals something over x plus 2. You can put that in parentheses, plus something over x minus 1. So what you're doing is you're splitting up the factors in the denominator so that they're separate. That makes them simpler, and then in calculus when you need to integrate, sometimes that's helpful. Okay. So I just kind of threw that in as the calculus go-to here. So the denominator is linear. The numerator is going to be 1 degree less. So because it's 1 degree less than a linear factor is just a constant factor. And we're going to represent a constant factor with a variable. We're going to use the letter capital A. That's traditionally used. And then for the other numerator, it's also going to be a constant because it has to be 1 degree less than the denominator. And so that's going to have a constant of B. We have to pick a different letter, so that's what we'll pick. Okay, that's the setup for this problem. And like I said, the setup is the big part, so you have to kind of know to identify how to set it up. Here we had two factors. They were both linear, and they're different, right? Okay. All right, so now we continue. We want to get a common denominator. That means multiplying up here by x minus 1 and multiplying over here by x plus 2. Now we know the denominator is what it's supposed to be, so I'm not going to write the denominator on this next step. What I am going to do is I'll write this out. A times x minus 1 plus b times x plus 2. That has to equal the numerator that we started with, 3x. Okay, so now we get 3x equals, distribute here, ax minus a, and bx plus bx, like that little blue box, plus 2b. So Traditionally, we're going to put the constants, the coefficients, numeric coefficients in front, then our letters that we're using like A, B, C, D, and then the variable. And I've always seen them done in terms of X, so we'll just say that. Okay, now comes step 3 where we're doing this matching idea. Over here we have one term on the left-hand side. It is a 3x. That 3x has to match to the x terms on the right. So 3x has to equal ax plus bx. Or I can write it, let me write that. 3x has to equal ax plus bx. But then that means 3 has to equal a plus b. So when I add those coefficients for a and b, that's going to have to equal 3. That's the equation I want to work with. I don't really want those x's hanging around. They're just going to cause problems. Okay, sorry. Now, I have two variables, right, a and b. I need another equation. But if you'll notice on the right, I have two constant terms. I have a negative a and a 2b. So negative a plus 2b. Well, that has to equal the constant on the right-hand side. But there's no constant over there, so it's 0. So we're going to write it that way. And then that gives us a second equation in terms of a and b. This is a system of equations. This equation right here and this equation right here make a system of equations that we can solve. Now, we know how to solve systems of equations. There's all kinds of different methods. You could use matrices. I'm not going to. I'm just going to say, hey, if I put the a, if I'm looking at the right equation, if I put the a on the other side, I get a equals 2b. And then I can simply substitute that 2b in for this a. And that's going to give me a new equation, 3 equals 2b plus b, or 3 equals 3b, or 1 equals b. So pretty nice that it's solved that way, and we found out what b was. Now I'm going to take my value for b, and I'm going to go back and plug it in here. So I'll have a equals 2 times 1, because b is 1, so a equals 2. And that didn't leave me much room. Okay, now I have to write the decomposition. So maybe I can go, all right, I have to remember which one's which. So a is 2, right? And that's over the x plus 2. And then I have to remember my denominators here. Okay, so here comes the decomposition. 2 over x plus 2. And then my b was 1 over x minus 1. I know you can't see it, but what we had set up was a over x plus 2 plus b over x minus 1. That was the setup. So this is the decomposition right here. And now you have two separate rational expressions where the denominators are just one factor. In this case, those factors are linear. Okay, so that's the example.